Okay, this is Chapter 6 review. The very first thing we're going to do is solve by graphing. So we have to get each equation in slope-intercept form. So we're going to subtract 6x from both sides. Then we divide by 2. So that's y is equal to negative 3x plus 8. The second equation, we're going to subtract 3x. And we get y is equal to negative 3x plus 8. Now, if you will notice, both of these equations are the exact same equation. So, when we go to graph, we will only get one line. I'm going to go down 3 to the right 1. So each equation is on top of each other. So the solution is infinitely many solutions. If you happen to get two equations that have the same slope, they're parallel, and the answer to that would be no solution. The second one is using the substitution method. We want to solve for the variable that has a coefficient of 1. X has a coefficient of 1, so we want to add 3y to both sides. So when we add 3y to both sides, we get x is equal to 3y minus 2. We are going to substitute that into the other equation wherever we see x. We're going to do the distributive property. 9y plus 2y is 11y, minus 6 is equal to 16. Add 6 to both sides. We get 11y is equal to 22. Divide both sides by 11, and y is equal to 2. Now we're going to plug in y right here. It's 3 times 2 minus 6. That's 6 minus 2, which is 4. Now, to check, we need to plug the ordered pair 4, 2 in. So the very first equation, 3 times 4 is 12, plus 2 times 2 is 4, and 12 plus 4 is equal to 16, and that plugs into the first equation. The second equation, x is 4, minus 3 times y is 6, is equal to negative 2. And 4 minus 6 is equal to negative 2, so that also checks. Now this equation, we're going to again solve for the substitution method. We're going to solve for y, because that has a coefficient of 1. So we're going to subtract 3x on both sides. Okay, so we're going to solve for y, so we're going to subtract 3x. So that's y is equal to negative 3x plus 5. We're going to substitute this into the other equation wherever we see y. So that's 6x plus 2 parentheses negative 3x plus 5 is equal to 10. So 2 times a negative 3 is a negative 6x plus 10. Now here, your variables go away. So you get 10 is equal to 10, and that is a true statement, which is infinitely many solutions. Okay, we're going to solve this one for x. So we get x is equal to 6 minus 2y. Plug this into the other equation. It's 18 minus 6y plus 6y is equal to 8. Here the variables go away. We get 18 is equal to 8. That is a false statement, so the answer is no solution. Okay, now we're going to do the elimination method. The elimination method is where we want to get rid of one of your variables. If you will see that x has the exact same coefficient of 1. We want one of them to be a negative x. So we can multiply either equation by a negative 1. I'm going to multiply the top equation by a negative 1. So that's negative x minus 4y is equal to a positive 4. Bring the second equation over. Now the x's go away. So we're going to add negative 4y to 10y and get 6y is equal to a negative 12. Divide by 6, y is equal to negative 2. Now we're going to plug in y equals negative 2 in one of the original equations. I'm going to plug it in the first one. So 4 times a negative 2 is a negative 8. Add 8 to both sides, and we get x is equal to 4. So my answer is 4, negative 2. Now this problem we're going to do the elimination method. Notice that none of the coefficients are the same. If we opted to get rid of the x's, what's a least common multiple of 3 and 5 would be 15. So we would need one to be a positive 15 and one to be a negative 15. Or if we chose to get rid of your y's, what's a common multiple of 4 and 2? 4. So one would need to be a positive 4 and one would need to be a negative 4. So if we get rid of the y's, we only have to multiply the second equation by a negative 2. So we just recopy the first equation. The second equation we multiply by a negative 2, so that's negative 10x, negative 4y is equal to negative 22. Now my y's go away, so that's negative 7x is equal to a negative 21. Divide both sides by negative 7, and we get x is equal to 3. Now we're going to plug in 3 into either one of the original equations. I'm going to plug it in the very first one. So that's 9 plus 4y is equal to 1. Subtract 9. So that's 4y is equal to negative 8. So y is equal to negative 2. So my answer is 3, negative 2. And don't forget, you're supposed to check all of these by plugging them back in for x and y. Okay, the last one, we're going to solve each equation for a while. We have to get it in slope-intercept form, so we're going to subtract 6x. So that's 2y is equal to negative 6x plus 16. Divide by 2. So that's y is equal to negative 3x plus 8. The second equation, I'm going to subtract 2x. So that's negative y is equal to negative 2x plus 2. Divide each side by a negative 1 because that's a negative y. And when you divide by a negative 1, it changes the sign of everything. Okay, the first equation, the slope-intercept is 0, 8. And we're going to go down 3 to the right 1. The second equation, your y-intercept is negative 2, 0, negative 2. We're going to go up 2 over 1. Or down 2 and backwards 1. And you will see that they cross at this point right here, which is the ordered pair 2, 2. And don't forget, you can also check this into each equation to make sure that you graphed correctly. And that is the end of Chapter 6 review.